Hello again! In the last video, we finished setting up the functionality to deal with collecting pickups. And so now it is time for us to turn our attention to the concept of power in the game. So we'll be able to collect pickups and get power from the batteries, and the game will drain power from the character. So in this video, we are going to add the power variables and handling to both the battery and the character. Then in the next video, we'll start adding gameplay logic to actually use the power. So let's go ahead and get started. We're first going to turn to the battery class. Here's a battery pickup here in Visual Studio. And we are going to need a value to represent power. So we're going to make that a variable in the class. That is going to be one that is protected so that if we happen to have derived classes, they'll be able to access that. This is a floating point variable called battery power. Okay, now this is going to be a U property, and we're going to make this a replicated value because we will want to know what that is on the client for rendering information and other various purposes potentially. So it's going to be replicated. It will be edit anywhere, so we can make changes to it in Blueprint. We'll make it Blueprint read write. And we'll put it in the power category. And then we're going to add our meta keyword, blueprint protected equals true. I don't think we've used this before. If we have, I'll just say real quick. Now, blueprint protected basically just means that we're able to access this even though it's a protected variable. So here's where we're going to set the amount of power the battery holds. Okay? And then, of course, in order to access that outside of the class, we're going to need an accessor function, a getter, so to speak. It'll be a float, and we'll just call get power. This one is not going to be a U function or anything. We're just going to leave it. We're only going to use it in C++ for now, so we'll just leave it without any markup. So this is a public method to access the battery's power level. And we'll go ahead and I'm going to try our little shortcut. The control period enter creates that for me, and then I'll just add the implementation right here, return battery power. And just to verify that, we can flip over to the CPP file, and you'll see down at the bottom it's added that get power function for me. And of course, we'll also want to, while we're over here, set some value for default. And of course, this is something that designers may want to change or tweak down the road, but we'll go ahead and set a base value for the power. Let's go ahead and make it 200. That way it's an even round number we can look at in the editor, in the logs and stuff. Okay, so it's 200 and we're getting power with the accessor. All right, so now are we done? Not quite. Remember that we have added a replicated variable, which means we got to add our networking scaffolding, our networking boilerplate code that we need. So let's go ahead, and this time we're going to copy it. So I'm going to go to somewhere we've used it already, the character, copy this, and drop down below my constructor and paste it. Get lifetime replicated props. And then let's see if IntelliSense can actually do this for me. Perfect. We're going to do the implementation. We'll call the super version of get lifetime replicated props, and we pass in out lifetime props. And then we need to declare our replicated variable, which is do rep lifetime, and the variable is battery power. We're going to put in a battery pickup, and the variable is battery power. Okay, and of course we need to flip over to the CPP file and add our header, include that header for Unreal Network. Okay, that will take care of the issue with the squiggly lines as IntelliSense catches up. And we are good to go there with the battery. So now we have the battery with power and its replicated value, and we have an accessor to get it. Now we can turn over to the character because the character needs some power as well. Now in the character's case, we need a couple of things. We need to know where the character starts. What is the starting power, the initial power value, and then we're going to track that power as it goes up and down over time during gameplay. So we need two variables for the character. The first of those we're going to put in the protected space here. We'll just drop it down at the bottom. And this is going to be our, it's a float of course, and we're going to call this our initial power. This is going to be also U property that is replicated. And we're going to go ahead and make this one the same kind of thing. We'll make it edit anywhere so designers can mess with it. Blueprint read write. And we'll put it in the power category. And we'll go ahead and add the same keyword. Blueprint protected equals true. Okay? And this is the character's starting power level. And then we're going to track that power over time, but that does not need to be visible to or accessible by anyone. So we're just going to make this a private variable. That's going to be our current power. This is going to be also replicated, so we got to add our markup to it. So it's a U property, it's a replicated value, and it is visible anywhere. So we may want to do something with rendering for that, but not editing. So category is power. Okay, add our note. This is the character's current power level during gameplay. Okay, great. So now we've got that. And of course we're going to need the same kind of accessor functions. So we'll go ahead and make those public. So we'll go up here to our public section and we'll add that right down here. And we'll call these, it's going to return a float, get initial power, and we'll make one that is get current power. Now, we want these to be U functions. It's going to be blueprint pure, and it'll be in the category power. And of course, since it's a U function, we can't use the force inline. So let's just copy and paste that same tag there, and let's add our comments. So this is access to the character's starting power, and this is access to the character's current power. Okay, now we need to implement those. So we'll go ahead and use our little shortcut, Control period and enter. I don't know if it's actually faster and we have to wait on IntelliSense, but that's okay. It will return initial power, and then we'll do the same thing with current power. Get current power will return current power. That's pretty much all we have to do with that. Okay, and now we also want to be able to change the power level. So now we have the power we're able to track, but we want to change it. So this is going to be where we're going to actually update our power. So we'll go ahead and add that here. We'll call that's a void function because we don't really need to return anything. Let's update power, and we need to pass in a value for the change in power. And when we talk about the change in something, we usually use the word delta. So like when you look at a tick function, it says delta time, so that's the change in time, the amount of time that's changed, and here we're updating power, so we're going to pass in delta power. So we'll pass in the amount of power to change it by. Now this is a U function as well. It is going to be blueprint callable, and remember, in the multiplayer case, we need this gameplay logic to all happen on the server. So this is blueprint authority only. So we don't worry about this running on anything but the server, and we'll put it in our power category. Okay. Now this one, we want to make a comment, but we also want to put a note about the parameter, the delta power parameter. So we set it up this way. So this updates the character's power level. Make a note about it. And we say at param delta power, and then we describe it. This is the amount to change power by, and it can be positive or negative. So this one is, because we can pass in a positive power or a negative. We can add power or take it away. So it can go either way. So we'll put it in that way. And now we can go ahead and turn to the implementation of this. So let's go look at actually implementing the function to update power. Give me 1 second. We'll flip over to the implementation of the character here, and we can put it up here by the other, there's the getters. We'll put it right here. So this is void a NMP game character update power. We pass in float, whoa, turn on caps lock, delta power. Okay, so as per usual, we throw in our authority guard to make sure this only gets called on the server, even if it's marked blueprint authority only. And we are going to increase or decrease current power. And we do that with simply saying that our current power plus equals delta power. And that's it. So that will be how we update our power. And that is pretty much all we have to do. There is one other caveat though. If you were to actually compile this, and actually let me just go ahead and illustrate this. I'm going to compile. So I hit build, it compiles, and everything's going to be grand, unless I did something wrong. But there would be a problem. If you actually go and run this, when you run this in the editor and try to test it, you're going to see that the client is going to crash as soon as the client spawns. The game is just going to crash inexplicably. The reason is because we've declared new replicated variables, but we forgot to add our replicated tag here. We need to declare them as when we replicate them, do rep lifetime. If we don't have that, then the game falls over. So if you try to run this, or you try to run the game after adding replicated variables and you get weird crashes, make sure that you've actually done this part. So we need to add that here, and that is, we'll do that 2 times, and one of them is initial power, the other is current power. So we have to make sure we do that in order to prevent the game from crashing. Okay, but notice the compiler did not help us out there, because the compiler has no idea that that was supposed to be the case. So this is going to be something that's on you as the programmer to notice and to be able to hunt down. So again, we'll hit compile and all will be right with the world. Now we've taken care of that. So now our batteries have power. They have a power level. We can get access to it. Our characters also have a power level, both initial and current, and we can update that. And all that stuff is replicated, so it'll show up on the client for us to do something with for visualizations later. So that is it for this video. And in the next video, as I said, we're going to actually start implementing some gameplay logic to use the power that we now have. And I will see you